Okay, again, good morning everyone. So at this time, we will tackle about trigonometric identities. So these identities can be used particularly in proving trigonometric identities. No? So magamit na tanan sila, daghan ni actually. So magamit na ma-apply natin siya particularly on some of the application for or problem solving regarding trigonometry. No? So, identifying or proving trigonometric identity also, direct mo tibali niya ito ang reference. No? So, magamit na ito siya. So, first, we have here, sine theta is equal to 1 over cosecant theta. So, first identity. No? The second one, we also have cos theta that is equal to 1 over secant theta. Katulo, we also have we have tangent theta is equal to 1 over cotangent theta. Okay? Kapay tulo ani, no? Kapay tulo the inverse for this one. We also have here, okay, cosecant theta is equal to 1 over sine theta. Next, we also have here secant theta is equal to 1 over cos theta. The last one, okay, for the first 6, we also have cotangent theta is equal to 1 over tangent theta. Okay? Another one, we also have here, we know also that tan theta is equal to, we have sin theta over cos theta. Tan sin cos, no? Another one, we also have here, cotangent theta is equal to cos theta over sin theta. Composite, no? So, kaning unong kabuok, 8 kabuok, magamit ni sila actually in proving trigonometric identity. So, we will add 3 for that. Those identity is for Pythagorean identities. Okay? So, by the way, I will erase this one so that we can derive, no? We can derive for the Pythagorean identity, the three Pythagorean identity. Pero murag masigo lang sa diri siguro ng area, no? So ato na sa siya ilahi, no? For the Pythagorean identity, we let the angle theta be in standard position. Okay? So diri si 1, no? Diri si angle theta nasa standard position. This one is our y-axis. This will be our x-axis. This one is our, kanina nga side ng triangle. Yung hypotenuse is r. This one is our, what is this? This is our y. Okay, parallel man siya sa y, so y lang dapat siya. This one is for x. Okay? Remember always, no? Sa sine, remember that sine theta is equal to opposite over hypotenuse, and for cos theta is equal to what? Adjacent over hypotenuse. So gamito natin ni sila nga information. Okay? Or opposite over hypotenuse is just equal to kaning sine. Opposite over hypotenuse is y over r. But for adjacent over hypotenuse we have x over r. Okay? So remember, to derive actually the Pythagorean identity, we can use the equation of the unit circle, which is the x squared plus y squared is equal to r squared. Okay, from this given formula or Pythagorean or the unit circle equation, we can divide each term by r squared para makuha natong first identity, no? So we have here x squared over r squared plus y squared over, we have r squared is equal to r squared over r squared. Remember, usa ni x over r? Natay x over r, that is cos theta. Naka-squared, so we have here cos squared theta. Plus, natay y over r, no? Y over r, dala, sin theta. Naka-squared, so we have sin squared theta is equal to r squared over r squared is 1. This one is our first identity. Okay? first identity nga Pythagorean. Next, from this given first identity, we can actually derive another Pythagorean identity by dividing each term by cos or sine. Pwede. So, naman natin si cos. No? Cos squared theta over cos squared theta plus sine squared theta over cos squared theta is equal to 1 over cos squared theta. Then we will have to simplify. Kani mo 1 ani. So 1 plus sine over cos, that is tan, no? Tan is equal to sine over cos. So we have tan squared theta is equal to 1 over cos na natin, no? Natay 1 over cos, that is second, no? Then naka-squared, so we have second squared theta. This one is our second Pythagorean identity. One. Next, multiply ng cos there is a first, pwede ko na mag-divide each term by sine, no? So that will become, from that also, we have cos squared theta over sine squared theta plus sine squared theta over sine squared theta is equal to, okay, is equal to 1 over, we have 1 over sine squared theta. Okay? Ilan man yung isa mo ni? Cos over sine. 3. Cos over sine, which is cotangent. So we have cos squared theta plus 1 is equal to 1 over sine. 1 over sine 3, which is cosecant. No? Cosecant squared theta. So this one is the third Pythagorean identity. So 9, 8 na po, plus 3, we have 1, 2, and 3. So magamit natin na sila actually. So at this moment also, I will give you an example on how to apply the given trigonometric identity improving trigonometric identity. So I will erase first this one. Remember always this identity. Remember that you cannot answer any problem regarding on proving except or unless you cannot memorize this one. Pero actually, hindi man siya necessary kaya nga ato give siya 100% i-memorize, no? All we have to do is we will have to familiarize about the concept. Kung makabalo ta sa concept, kabalo sa tao saan pag-derive to. So kung malimot ka sa Pythagorean identity, yung bato ning ato nimo, no, i-derive nimo ang katong tulo ka buok. Okay? So we'll have an example on how to use those identity. Okay? Let us have the first example. Okay, we have here prove the identity. Prove the identity 1 minus sine to the 4th theta over k1 plus sine squared theta is equal to cos squared theta. Okay? So how do we simplify that one? In here, what we're going to do is we will have to simplify the left-hand side, in which our goal is to obtain the quantity the same as in the right-hand side. Dapat pag mag-simplify tani, makuha tani cos squared theta, so that we could say that this one, or they are really an identity. No? 1 minus sine to the 4th theta, actually we can make use of factoring. No? The concept from the quadratic equation or quadratic. No? Sa quadratic equation actually, we can make use of factoring for us to identify the solution, no? So dire pwede po natin siya ma-apply ang algebra, no? So by factoring that one using 2 binomial factor, 1 times 1, what? Sine to the power of 4 is, that is sine to the power of, no? We have 1 minus sine squared theta multiplied by 1 plus sine squared theta. Okay? So when we multiply, we could obtain the same in the decimal 1. 1 minus sine to the 4 theta. Okay? Over, in the denominator part, we don't need to factor. No? Hindi na natin i-factor siya. So, that is 1 plus sine squared theta. As is lang siya. No? Then, makancel din siya. Ano bilhin? 1 minus sine squared theta. Yan naman tayong Pythagorean identity. No? Katong sine squared theta plus cos squared theta is equal to 1. Tama? So, magamit natin na siya. No? Okay? So, we know that cos squared theta in here is equal to 1 minus sine squared theta. Therefore, kaning 1 minus sine squared theta, tara, cosine squared din eh. No? Cos squared theta din na. So, we have here cos squared theta. And that is correct, no? Na-prove na to. Therefore, we are really an identity. Okay? Another example. Okay, another example. So, erase na yung area para pag-plot by example. Okay, example, prove the identity. Example number 2. We have here cos squared of x times 1 plus tan squared of x, okay, is equal to 1. 1 daw, no? So we want to prove that this given identity or equation if they are really an identity, no? Cos squared x multiplied by the quantity of 1 plus tan squared x is equal to 1. Okay? So, solution. Remember always this one. Okay? That this one actually is found in our Pythagorean identity. That 1 plus tan squared theta, or we will have to use variable x para pareha. 1 plus tan squared x is equal to secant squared x. Nasa itong identity kanina, no? 1 plus tan is equal to secant squared. Okay? So instead of writing 1 plus tan, we can write secant squared in here. So we have here cos squared x times. Instead of writing 1 plus tan, I will say value which is secant squared x. Okay? Next. We know that secant squared x, okay? We know that secant squared x is equal to 1 over cos squared x. Pwede ko talaga nito, no? Instead of writing this one, sulat natin yung 1 over cos squared x. So we have cos squared x times 1 over cos squared x. Cancel na din siya, no? Nabilin 1. Okay, 1 ang nabilin. So, therefore, we are really an identity. I hope you learned something about this one, particularly on the different Pythagorean, the different identities, so that you could answer maybe your quizzes or assignment.